Well, hello, fellow developers. We are thrilled to have you back to join our latest meetup within the JavaScript Fury Days. The topic of today's meetup is monkey patching in JavaScript. And leading tonight's event is Luís, Filipe, Teófilo, elite software and AI engineer, senior lecturer at the Polytechnic Institute of Viana do Castelo, and former director of engineering at Toptal. And it's not the end. He is also a CTO at infraPLAN LLC. With that pretty extensive experience and knowledge in the field, Luís is just the right person to talk about JavaScript and to host this series. As usual, the meetup is scheduled to last around 75 minutes. And I want to say hi to Luís. Luís, how are you doing today? Thank you for joining us. It's a pleasure to see you again.
Hey, Darina. It's a pleasure to be here once again. I'm pretty excited to talk about these topics, and a little bit sad, to be honest, because it's the last one from this series.
The truth, because I already got used that every Wednesday we gather and we have something going on, and people join, we make a raffle, and we keep on keeping our community, the Lemon.io community, up. And I want to highlight that today we also will hold a raffle for those who post the most intriguing questions. So do not hesitate, ask your questions. Luís will stop during the talk and answer all your questions. And later on, lucky winners will receive prizes from the Lemon.io. Lemon.io, we are the marketplace for experienced developers. We gather a pretty extensive community of more than 1,000 developers from more than 30 countries all over the globe. So join us. And I pass my words back to Luís. Hello, Luís, and let's proceed.
Yeah, let's proceed then. So, of course, you will see day 2 here, but this is actually the 4th presentation. This is one that I had to unfortunately postpone because I got sick on the day of the presentation. But here I am to talk about these topics. So the topic for today is monkey patching, which is a topic that correlates with the previous ones. So essentially, monkey patching, when used with care, is an opportunity to turn certain limitations on your code or on your software into innovation and with creativity and resourcefulness. So the idea here is to take advantage of the full potential of what we can provide. So this technique is applied to certain. This technique can be used in certain programming languages. So I will focus on JavaScript in this presentation. So just to do a quick review on the last episodes of this series of talks. So the very first one, we talked about reverse engineering in the context of extending applications. So essentially try to through the functionality get access, or at least partial access, to the code, and try to adapt an application, try to learn how an application works so that we can extend it. So we talked about, we introduced several JavaScript related features such as monkey patching. I talked already about monkey patching in that presentation, but it was very briefly. So today, the talk will be entirely about this topic. So as for the other presentations, we talked about on the basics of creating browser extensions. And on the following one, we tried to make the development of extensions a little bit more professional by inserting libraries of components and frameworks. For instance, we introduced React components, injected React components into web applications, and we showed, and I tried to show how that can be done, and in a more professional way. So you can review all these talks in the links that are here in the presentation. So, of course, monkey patching is of extreme relevance for all these topics, because it's a technique that is very related to the creation of browser extensions and existing applications. Because what are we talking about? We're talking about patching existing code on a runtime level. So in order to extend an application, we typically need to modify the way it works. So this is one of the techniques you can use to do that. So this is the outline for the presentation today. So I'll first start with the motivation, like I always do, and then I'll go to some definitions. I will talk about techniques of monkey patching inside JavaScript with the JavaScript language. Some of those might be transferable to other programming languages, but I will mostly focus on JavaScript. I will talk about advantages and disadvantages and limitations about these practices. I'll provide some practical examples. At least two of them are very interesting, because those were very practical examples of problems that I personally had to solve in my years as a software developer. So I will share those with you, and then I will conclude the presentation and do a quick Q&A session. Regarding questions, feel free to anytime during the presentation to post your questions in the chat, and as soon as I see them, I will try to address them so that you can follow throughout the entire presentation. Just to quickly give you an overview of my motivation. First, I'll start with my story. So I've been doing many things, many different things as a software developer. So of course, the very first thing, the very first interest started with gaming, like a lot of 90s people. So they play games, so they think, hey, software engineering must be a cool subject. In the end, we all try to skip away from working on games, because it's actually very difficult. It's probably one of the most difficult things to do. Anyway, I started to do some hacking. I used to one of the first things that I did was hacking game ROMs for just for fun, changing the strings with an X editor. Then I started getting interesting. I did a couple of small websites for my topics of interest when I was young. Then I decided to attend college, did a PhD on AI, worked as well as a software engineer, did teaching over the years, also worked on matching and recruiting, and as a manager as well. One common denominator in all these jobs, even the less technical ones, is that I never stopped coding. Of course, I can code the functionality to provide a value to the platforms I'm working on, or to my clients, but I also do coding to help myself. It's very frequent, even if I'm doing something completely outside of my typical tasks, to just try to automate anything that I'm doing, if programming can help me with that. And this is something I strongly suggest you to do. So, and these kind of techniques typically allow you to be very fast. For instance, when changing functionality or trying to extract some data or doing some repetitive tasks like I don't know, renaming files or such. So these small tasks that you can accomplish with very simple instructions can be very helpful, even when we're not talking about our development jobs. So why did I add monkey patching to this topic, to this series of presentations? So of course, since it allows for modifying existing code, it can be used to extend applications. So that's the axiom here. So of course, another advantage of this is that in order to do monkey patching, you don't need access to the original source code. You just need access to be able to interact with the runtime of the code. So this aids also in the extension of applications. In the context of applications, web application, of course, since you have access to the runtime, you can add new features, either directly on the console of the web browser tools or through a browser extension. So as I demonstrated in the previous talks, we can add new features without too much difficulty. And this code, these features that we have, can be used to extract information or modify the behavior of applications. We can also use it for prototyping new features. Sometimes we want to apply a quick patch to see what happens, and this can even be done, of course, with with a lot of care in even on production applications. And another reason is that in certain ways, this monkey patching in certain examples, and I will show you those, can provide a cleaner code, while in another, and that's the bad part, it's a bit less maintainable and a bit less secure, but it's cleaner. So I will explain why later on in the presentation. So let's go to definitions. Monkey patching is a technique that allows developers to modify or extend the behavior of existing code on the runtime. So this is this monkey patching is not meant to be used before runtime. Of course, you can import files with patches. Given the nature of JavaScript as an interpreted language, the runtime doesn't necessarily mean, hey, go to the console and insert the code. No, it could be an imported file that does the patches. That still counts as runtime because the code is not compiled, is interpreted. So anyway, we are interacting with objects that were already imported to the runtime. It can be useful to add new features, fix bugs, or even improve performance in some cases. I've also found it useful to do some certain integrations. And however, of course, there are risks and concerns about these practices that we always need to take into account. Again, I will provide you some examples. Of course, there are several ways how we can do this. So this can consist of very simple things like changing a variable, but we can go for more complex things like overriding a method or adding new properties, or even we can also delete update properties. So there are many things that we can do. This is a common trait between dynamic languages like JavaScript. where objects and functions can be modified on the fly. These are some of the advantages, some of the benefits that we can see from using monkey patching. So in certain ways, since we are able to extend existing libraries, we can improve the flexibility and the agility. We can also speed up the development. We all use third-party libraries in our projects at some point. So, for instance, if we know how, let's say we are using a library, we find a bug in that library, and we know how to fix it. So this is a very good technique to fix the bug. Of course, we should report if it's an open source library and give our contribution to the community. But even so, while that is not officially released and the pull request accepted, you can patch on your end using this technique, and we don't need to wait for a release of the application. We can also it also makes it easier to adapt to certain requirements or unexpected situations. It handles browser compatibility. This is less and less a problem because most of the used browsers are Chromium-based these days. A couple of years ago, this was more of a concern. So we used monkey patching to adapt certain libraries to behave in a similar way between browsers, between different browsers, like the concept of a polyfill that would add missing JavaScript functions to outdated browsers. But yeah, this is less of a concern these days. Still, I believe it's used in certain cases. So of course, patching our dependencies when upgrading is not an option. So sometimes we need certain functionality from a library, but we can't afford to upgrade because we are too dependent on a certain version. So we might need to adapt and patch that version. It can be used for debug, so we can inject debug symbols and logs in the functions that already exist, and improve code readability in some cases. So let's jump into some examples. So let's say that we have an authentication library that has some login method, and let's say that we want to support a new way of logging in. So this is so let's assume that this is declared in some other file from a third-party library. So we can do things like this. So essentially, we are replacing the login function with our own implementation. So we added a new login possibility. We added a third argument to the function to use the new login method. So the original one is still available. So, and there are things we need to take into consideration. For instance, we are storing the original. So JavaScript has a functional nature. So functions are also variables that we can use. So here we are storing the original login function into a variable so that we can call it in case we are not using the same version that we were using before. So a small detail about this example, which is something that I tend to use. So you see that you could have easily equalize login to a function directly. The reason I'm not doing that, it's because I want to maintain the scope, maintain the original login inside the scope of the function that we are creating. So I created a function that returns the function that will replace the original one. So this is something that you can do in our. So otherwise, it could be the case that you have to store this original login as a global variable or on the top scope, which could not be the desirable because we way to do things, because you are introducing another name to your scope. As per code readability, so let's say we have this function render a greeting. So basically we are saying hello, hello lemon.io. So we can create easily the function, and we are trying to so we are capitalizing the name that we are going to print. But this code is a bit harder to read than this one. So in this case, what are we doing actually? We are extending the prototype of the string built-in object. So of course this is still a little bit hard to read. So we need to think, oh, we are getting the first char and putting the first char in uppercase, and then putting the rest of the string starting from char 1. But still, this allows us to write things like this. So name dot capitalize, because name is of type string. Assuming name is of type string, of course, there's no guarantee in JavaScript, but this is meant to be used by this argument is supposed to be a string. But anyway, we can use name.capitalize. So we use the capitalize function as if it was part of the original string library. So if we read the render greeting function now, it's much more compact and much easier to read. Of course, this has implications. So first of all, we don't have a guarantee that the string library now implements a function or a method named capitalize, right? So it could be the case by doing this, we are changing the capitalize method that is built in to something else, and this means that if there are dependencies or other parts of built-in code or other libraries that use the capitalize function, that this could make it harder to track those. So use this with a lot of care. There are certain situations where it's safer. I will address that following into the presentation, but generally this is not the best practice in terms of safety because of the reasons I explained. So this of course gives us the risks and concerns. Since there might be dependencies from the capitalize function or any other function that you have, if the name is being used anywhere, this can lead to unexpected behavior, because if someone is using patching the string class to have the capitalize function, this means that that any library using that name over strings will potentially be using a different behavior, because the capitalize, even the name, it's not clear that it will just capitalize the first letter, right? So capitalize could be, oh, capitalize the first letter of every single word. So there are many interpretations of the name, and we could be providing a different implementation, which will affect other libraries and other things that depend on that function. So this is one of the risks and concern about doing this. Of course, to that extent, code is also it also makes code harder to maintain and understand, especially if we have multiple developers in the team, because you can literally do this patch in any part of the code, and it's not so easy to find. So it's a good practice to keep some documentation on when and where these patches are done among the team, because, as I said, this can be literally be done anywhere inside the code. So there is no limitation, because things like classes like string are global objects, so they can be accessed anywhere. In some cases, we can also introduce even security risks. So in any case, regarding compatibility, in some cases this can actually help, and I can explain why. So an example of compatibility issue. So basically here we are using here the reduce function. So basically we are summing all the elements of the array, and if we use the inbuilt implementation, it will provide 15. But as you can see, we can replace the original reduce function and to return minus the original reduce, so the negative of the reduced number. Of course, this is not something you want to do, but still, this can be done. And it will affect the code. As you see, the new sum for the exact same array will provide a different result. So we need to be very careful when doing this. Another thing that we can do, and I've seen this personally. So a common flaw in security in many web applications is that validation of data is only being done in one of the sides, either on the server side or on the client side. So in case it's mostly so if it's done on the server side, so if it's only done on the server side, I mean, it's not ideal, but at least we will not introduce faulty or unexpected data into the databases. But if the validation is only done on the front end side, believe me, I've seen that, or at least have a more rigid validation on the front end side rather than on the back end side. This can lead to security issues. For instance, one thing that we can do with Monkey Patch is to skip validation of the forms. A lot of form validation happens after on this event, the submit event. We can replace the submit event to never do validation. So we can well, it's not as direct, but you can, in theory, put anything you want in the forms and then skip the validation of the data introduced in the forms. So that's an example of security issue that we can introduce by doing this. So in terms of JavaScript, what can we do to do monkey patching? So there are several things. So we can have a method to an existing object, modify an existing method, adding a property to an existing object, modifying that property, do the same to classes, or even manipulate the prototype of an object. So prototype manipulation, to do that, first we need to understand what is the prototype. So every object has a prototype. A prototype is also another object that allows for inheriting properties and methods from similar objects. So then we have this prototype chain, which is a series of objects linked all together through their prototypes. So if you have this object, my object, that can be anything, you have this object get prototype of, that will retrieve an object that has the description of the prototype of this object. Okay, and of course we can one thing that we can do is to create is to adapt the prototype of an object. So essentially, whenever you have an object declared as a prototype, you can add properties or add methods, and those can be used by any instance. So let's say we have this prototype that has a lot of several functions and properties. We are adding this property, my property, and we are adding a method to the prototype. So without interacting with the instance, we now have access to the function my method through that object. We can also use prototypes with what we call the constructor functions. So constructor functions are meant to build an object. So they are the closest thing that we have to class constructors, but in JavaScript. So essentially, let's say that we have this entity person that has a name and an age. We can create a function that instantiates a new person, and we can add methods to that constructor function that can be called from instances. For instance, we have this function, say hello, that tells my name and my age, and after I declared the constructor function, I can say, hey, Luís is equal to a new person, and I pass on the name and the age, and then I can call the function, the method, say hello over Luís. So this is somewhat similar to classes, but it's a bit, but it's way more dynamic than it. So of course, this means in order to properly understand how this works, we need to understand what the new keyword does in JavaScript. So basically, when we are saying Luís equals to new person, we are saying that the prototype of the object Luís is equal to the person's prototype. So this means that any instance with a new keyword will be able to call the methods present on that prototype. So this works similarly between constructor functions and classes. So I've shown you this example of a constructor function that creates a person. This is a alternative way of declaring the same kind of object. It's just a little bit easier to read because we don't need to interact specifically or visibly with the prototype, but it's still there. So this basically is adding the hello function method to the person prototype. So I'll just drink some water. So moving on, things that we can do with monkey patching. I'm going to show you a couple of examples of concrete examples. So things that that can even be useful. So let's say we want to create a method to count words on a string. We can, for instance, add it to the string prototype. So this way we can call the function from the variables that are of type string. So keep in mind that whenever you add this kind of function, this will be the instance. So if you use this format instead of arrow function, this will be the instance of the instance variable that is called over which the method is being called. So so basically, what we are when we do sentence dot count words, we are basically in this specific run, this will be the sentence variable. So this way we can have a very simple syntax to count words. So another example that I added is to extend the array prototype. So for instance, let's say that we want to add a function that returns true if we find any occurrence of a certain element. So function as any. This can be done like this. So we add as any to the arrays prototype. So we go through our elements and we check if the current element, which is this arrow brackets, equals to value, and we return true. So this way we can easily check if our array has a certain element. So it has the element 2 and it doesn't have the element 4. Another good example would be a group by function. So let's say that we have an array of people and we want to group the array of people by age. So this is in terms of syntax, this is a very readable syntax. Again, we are here extending the array prototype, which is not recommended in all cases, but still, if we take a look at the way this is being used, it makes it looks very very readable. So we are grouping people by their age, and it outputs for each age the list of sublist of people that have that age. So this is a common use case, grouping by some field inside our arrays. So this is more. This is also a good use case, good example use case for logging a certain behavior. Let's say that that we are looking that we need to know when a certain for each is called or when the for each function is called. So one of the ways is to replace the original prototype of the for each function by another one that logs the interactions with the for each function. So this for each will do the exact same thing as the original for each, but it will log one. It will log before and after the for each is called. So the same thing. For instance, let's say that we are using console log to log data into our application. Let's say that we want to have a prefix, say my app, in every log, we can do it very easily like this. So the console log will almost act the same way. So we are passing on all the arguments to the original console log function, but we are adding a prefix so that all messages will be prefixed with my my app. So we also can do this for other purposes. So for instance, there are certain cases where we need to let's say, for instance, manipulate randomness, because when we are testing an application that generates random numbers, of course, the behavior will always be different because we are generating something random. But sometimes we just need to force the application to generate a certain value. So this is a way of doing it. So we can replace temporarily the random function to always retrieve the same value, and then we restore back the old function that we were using. So I found this very useful when debugging any application that needs to use random events, so that I could control even. I mean, I'm replacing this by a constant, but for instance, you can replace for a random generator with a different distribution, where you will get more numbers closer, where the numbers will be more closer to 1 than 0, or that follows any known distribution, like the normal distribution, instead of using the uniform distribution, which is by default what JavaScript does. So this can be useful for you to debug your code when using random functions. So you can also attach properties. So let's say that we want to store the number, the pi number, to the math library. So you just have to put the name of the object, dot property, and attach it to a value. So we can also use define property to add new fields that can be accessed instead of adding a method. So so of course you could have get a current year function, but when we are dealing with data, when we are using when we are using certain variables, we rather use fields than methods, because method makes the assumption that we are doing some work inside, which could be the case for fields as well. But if we monkey patch the data object like this, with a field instead of a method, it becomes much more readable, especially if we have complex expressions that do I don't know, distance between dates, or number of years between two dates. It gets much easier to read instead of having get current year or get current month and all of that. So this is a way where a way of having properties that without using methods. So let me check the chat. I think we have a question from Andrew. Have you ever had a situation where monkey patching a function caused some upstream failure or issues that were not easily diagnosed or uncovered? Yes, that's that's true. And strangely enough, the monkey patch was not inserted by me. It was inserted by a third-party library. So I was importing some library that was doing monkey patching. I mean, this was a long time ago, and that library was changing the behavior of Ajax requests, and it created. I mean, in general, I wouldn't have any issues, but I was having a very particular request that was affected by that patch, and it was very, very hard to find, because I was never suspecting that that would be the case in a third party library publicly available. So that's why this is very difficult to detect. But and I've also checked that being the case in certain platforms. I've also seen it being used for security purposes. So basically, there was this platform, I will not name it, but it's a well-known platform that does monkey patching over the functions to query the DOM, like query selector. And they would change by their own function. So their idea was to make it harder for extension creators or other monkey patchers like me to extract data easily from that platform. So an easy way to you can actually see if the function was changed, because if you ever if you go to your let's say that we want to see if the query selector was changed by the web platform that we are currently using. If you type on the console document.query selector without calling the function, it will print on your console the prototype of the function, and it will have between brackets written native code. This means that the function that is being used, it's still the one that is using native JavaScript code. If the function was changed by in any reason, by any other library or by the web platform, you will generally see the prototype of the function, full prototype. So so yeah, to answer, short answer, yes, definitely. Let's move on. I'm showing another example of cool things that we can do. For instance, we can let's say that we want to on the promise class. A promise is a class that, of course, that allows for asynchronous coding in JavaScript, and it has several handlers and callbacks that are called when certain events happen. So the main one is then. So once the result of the promise is available, this callback will be called. So the idea here, it was to create a before callback. So even before the promise was launched, I want to execute some code. Let's say a code to log what is going on, or something else. So this is a way of adding to the promise class before handler, so that we can run code before the promise is executed. So so I provided you a couple of examples of practical things that we can do in terms of summary of what we can do. So we have prototype manipulation, property modification, function overriding, method swizzling, proxy objects, and global monkey patching. So this would be the 6 that, generally speaking, are the main ways of monkey patching in JavaScript. So I will provide you a template for each one. So prototype modification consists of just changing the function of a class. So we can of class or constructor function. So we type the name of the function dot prototype dot name of the method or the field and equal to a new function. So modifying the property is done can be done similarly, but in this case we are not modifying the prototype. We are modifying the property of a concrete object. So in runtime, so we are altering my property. Keep in mind that I'm instantiating these objects on top of the code, but this could be literally any object. So you can go to your global scope and start adapting methods and properties on your objects, and this will work. We can also do overriding of functions and other things. So let's say that we have this function declared globally. We can just reassign because whenever I call this function, it will take the name of the current scope. So if on the current scope of code I assign something else to this name, it will run the new modified function. Method swizzling, I've also shown some examples, but the simple template to do this is to basically change a function of some object, but always keeping the copy on or the reference on some other variable of the original method. Typically, this is more used to to add functionality. For in this case, we are adding login functionality to some method because as you see here, we are calling the original function with the arguments and by applying this reference. So this will the original method will behave exactly the same as it was before. I mean, one thing I actually forgot in this template, we should use a return statement, or we should return, because at least here we don't know if some method is supposed to return something. So you should have your return statement to make sure we don't lose this value to keep intact the original functionality. We can also use proxy objects. So basically, this allows us to listen to some property of a given object and modify its getters and setters. So whenever you retrieve or assign the variable, these methods will be called. So this is pretty. This is similar, especially the get part, to what the observer part. I mean the set part to what the observer pattern does. So we also have global monkey patching. I've shown you a couple of examples. This means changing a global objects that are globally available, like array, string, or even object. This is So this is a comparison overview of advantages and disadvantages of these practices. So the advantages, it's useful for extending code on runtime. It allows for fixing bugs or fixing integrations and patching third-party libraries. I use it more for that. Of course, allows you to build extensions, and it makes you avoid doing workarounds. So in terms of the cons, it can introduce compatibility and security issues, unpredictable behavior. I already gave you some examples. It makes things harder to test and validate in most cases. It's less transparent and predictable than other techniques. And there are one thing that I wanted to mention is that there are differences between what happens with monkey patching on client and the server side. On the server side, things work a bit different. So one of the challenges, especially when you're patching global objects, is that you never know. When you're doing on the browser side, you never know which browser is going to access the code. Because browsers keep being updated all the time, the JavaScript changes. The JavaScript libraries, core libraries are updated. They add new stuff all the time. So you never know if you are overriding something that already exists or that is going to exist in the future in JavaScript. However, on the server side, things work a little bit different. It's a bit safer to do this because you can control the version. So upgrading your JavaScript version, it's your option. Okay, so if you are in version 18.1 of Node, you can keep using that version. So you will know that the global scope and the global objects will remain stable, at least in theory, right? But in the case of browsers, it's much less safer to update global objects because of that reason. So I wanted to share some quickly practical examples. This first one is by any means recommended, but this is to show you that something that you can do. So this example is on React, and it allows us to change one of the most used hooks in React. So in this case, we are using a proxy object to allow us to change to invoke to update a variable without using the setter the setter function on the hook. So we could simply by using the new use state hook, we could update the value like this without needing to use the set state function. So this is an example case on how you can update a well-known library. Again, it's not recommended because it will affect the entire structure of your app. Plus, it will affect. It will also affect other libraries that likely use the use state hook. But still, this is something that you can do. Of course, in the case of React, I just recommend if you want to do something like this, just use a custom hook. But this is just an example, just to show you how powerful this is. Another example that I've personally used, and that it was very useful for me in the past, was especially in the context of creating browser extensions, where I had to manipulate the requests and retrieve information from the requests, is to create interceptors for HTTP requests. So most of the requests in the browser are handled by this object, this global object, in which we can try to monkey patch some code. So basically, my patch here was to modify the behavior of this class and to throw a callback whenever a certain URL pattern was matched, and that callback would allow me to change the body of the requests. So this was a particular use case where I was patching a web application where I needed to so it was an application that was abandoned already, but we still needed to use it. So basically, I created a patch to fix the requests that we were doing to the server, because the server has changed, and I needed to make some small adaptations to it. So basically, I created a singleton class, an interceptor, that would allow me to set an interceptor. So basically, an interceptor as an URL pattern and the callback function. So whenever a URL pattern, a certain URL pattern is matched, I would use this callback in order to change the body of the request. And as you see, I'm altering the prototype of this method. So I was able to catch most of the requests done by this global object, and I didn't even need to think about where those requests were implemented inside the code. So another example that I personally had. So this was with a library, a very good library called Leaflet, which is an open source library for interactive maps. So basically, it makes it very easy to render objects in a map, and it's very versatile, because you can use several different sources for maps and several different layers. So it's very interesting in case you want to explore it. So one of the things that I had to do that the library didn't allow for was I had an application where I was retrieving layers. So whenever you load a map, so typically when you see a map interface, typically your screen is divided in 16 tiles, so 4x4 tiles, and the leaflet downloads each one individually, sends 16 requests at first, and then as we move the map, it will send to the new visible tiles. So one of the issues that I was having, because I have a server-side functionality to retrieve tiles done by my project, was that in order to access my server, I needed to provide a token. Token access, and Leaflet didn't support token access. So I made a change to the tile layer. So this was a change that I made. So basically, whenever I had the token available on local storage, I would add it to the URL, and then do the fetch manually. So this is a simplified version of the solution. And one of the things that I wanted to mention, why did I use monkey patch here? Because I had this external dependency. I had a dependency on Leaflet, and I heavily on that specific application. I heavily rely on Leaflet. But one of the issues, one of the things that I usually do, because they are always releasing new features, is that I update frequently the library, and this is not something they will have to their library soon enough. So this feature, so this way, by doing monkey patching, even if I upgrade the library, since this will take care of the global object, it will adapt the global object to the new prototype, no matter what that looks like. Of course, this is not fully secure and upgrade proof, but this allows me to try to upgrade the library. The other option would be, hey, just go to the source code, leaflet source code, and change it. But that way, it would be much harder for me to upgrade the library if I needed a new version. So, as a conclusion to this presentation, so do you think it's worth learning monkey patching? What are your thoughts? So, just to do a quick recap, I gave you a brief overview of what it is, about the dangers and the issue, but also about the benefits. How to do it specifically on JavaScript. There are other languages that implement that allow for some monkey patching. We also discussed compatibility and security concerns. I gave you examples of some of the best practice and demo projects or demo code that I use to solve particular problems that I personally have. So, as final thoughts, it's obviously a very powerful tool, but it should be used with caution. So it must be very, very well documented, because anything that you can do can not only disrupt your code, but also third parties' code. And I mean, no one does an application without external dependencies these days. So you will have a lot of dependencies, and we don't want to introduce code that might disrupt those dependencies. Of course, monkey patching will also be likely necessary when extending an application. We have used it on the previous talks. We talked about that, and we not so explicitly, but I had to use some of these patches. Of course, use this absolutely only when you need, and try to avoid. I mean, of course, in some cases, it can provide a cleaner code, especially when you patch global objects. But the insecurity that it produces, it's probably not worth it in most cases. So use it with a lot of care. As a suggestion, try to keep all the patches localized in certain part of the code, and avoid using the global monkey patches to the global objects. Needless to say, always test your changes throughoutly. You can also write unit tests with the known frameworks, and of course, since we are talking about very sensitive functionality, make sure you cover all the edge cases so that we reduce the number of unexpected situations. And communication with the team is essential to make sure everyone is aware of what you're introducing into the code. And always keep in mind the maintenance issues, especially with web applications where you are not able to anticipate which browser is going to be used, and that will access to your application. So this is the end. So this was a summary of the calls of our talks that we have. So you can review every single talk on YouTube in Lemon.io page. So let's move on to the Q&A session. Thank you, everyone, for attending.
Thank you, Luís, for such an amazing and fulfilled with the knowledge talk. We have some questions in the chat, and the pretty extensive one.
Yeah. So let's take a look at the questions. So I think they all. So I already answered Andrew's question, and we have another question. So I've been using monkey patching for mostly 10 years ago in the before NPM era, when a typical way of using library was putting it into a vendor directory. Basically, there wasn't another way to change the lib behavior. We having the ability to upgrade it and replace implementation dynamically in runtime. Nowadays, when we have npm registry, and in most cases we need to fix a bug, improve functionality in external library, not our code. Isn't it better to use patch package to consistently patch the external codes statically on post-install stage for the whole team? Yes, that's a possibility. So most of the techniques that I mentioned here are in the context of creating browser extensions, where it will be more difficult to do that. But still, any of the options is viable. I mean, in the at first, you will probably do some. Just to be quicker, you will probably do some manual monkey patching just to test things out first, and then more formally create the patch package. Second, let's say the code we want to patch isn't open source. We are loading third party, and we need to use monkey patching. How do we deal with minified code in such a case? So dealing with minified code is not too easy. So because you will not have access to the names. I mean, you will still have access to the names of the external functions. So the ones that are being used and that are on the documentation. So basically, the way you do it, it's more or less the same way, except you will have more limitations when dealing with internal functions or methods or properties. So I think the main challenge will reside on those. In previous and similar cases, how do we deal with private members? By private, I mean mostly these variables that are hidden inside the closures. I try to avoid dealing with the private fields or private methods. I mean, not that it's possible in all cases, but my approach to the monkey patching is very like so. If people here know the C# language, which is one that I worked on for many years, they have the extension methods, and which somewhat they are kind of similar in some ways to monkey patching, but they only have access to what the library offers publicly. So, but of course, we can still replace with a keyword new names of the functions that we are replacing. It's a bit safer there because you need to use the import statement, so you are not replacing things on the global scope. So, but that's more or less the way I try to approach patches. So to use what is publicly available, because I have literally zero control of what the developer does with private fields. So I try to not deal with those. But there were cases where I had to. But I try to avoid. Let me see the next part. We want to patch a method, and it's not a problem to change it on the prototype level. But what if method uses some variable that isn't available externally? I mean, it will be case by case scenario, of course. I mean, I can't really answer this globally to all cases, but but I mean, if you are going to mess with private variables, typically I would say I wouldn't do it with libraries for which I don't have access to the source code. I mean, you can do it, but you will need to reverse engineer the whole thing. So I only interact with private fields if I have access to the source code and after I study it to see if it's safe without majorly altering the functionality of the method. So as for Tiago Oliveira, you know any course book material I can do to deep in this knowing? I mean, that's a very good question. I don't have any names by hand, but I can follow up on that. Feel free to contact me. I mean, I don't know any names by just now, but contact me on LinkedIn or so, and I can gladly give you some references that specifically handle these things.
And we will make the follow-up email and share Luís' contacts, and we will share the link to the Discord community where you can chat in person with Luís. And meanwhile, I would like to proceed with the special treat for the most intriguing questions. As I said before, lucky winners will receive prizes from Dilemma.io, and I invite Luís to choose the most intriguing question.
I think I'm going to select the one regarding the patch package. I found it a very good observation and a very good question. So and the other one is from Andrew. So those would be the two questions.
Great. I will reach out to Andrew and I invite the person who addresses the question about patch methods to write me an email so I can send a prize for you.
Yeah.
Congratulations, guys. And thank you for joining us today. And I invite you to follow the Dilemma.io community, follow our events. We will proceed with the live gatherings. The following events are on Flutter, on UX UI for developers. We will proceed with talks about JavaScript. And thank you for being with us. Let's stay in touch. And we wish you all the very best. And thank you, Luís, for those amazing months we had together with Dilemma.io and you.
Yeah, I will miss you, but we will definitely stay in touch. And it was a pleasure. And thank you for the invitation.
Thank you too. And I see the question in the chat on how to get and to watch previous videos. Right now, I will share the link. This is a link to our YouTube channel, to the live videos. We had 4 live videos from the previous meetups on the reverse engineering of web applications, developing browser extensions in JavaScript, extending existing application, and today's meetup, monkey patching in JavaScript. I will share it on LinkedIn right now. Thank you for being with us. Follow Dilemma.io community, stay tuned, and see you around online.